Hi there, and welcome to our lesson on literal equations. If you find this video helpful, please give it a thumbs up and subscribe to the channel if you haven't. Leave me a comment or a question below and let me know what else you would like to see on the channel, or if there's anything in this video that you would like some further explanation on. We're going to start off with some key vocabulary, and I always tell my students, I know vocabulary is not the most exciting thing, but it is absolutely critical that we know what we are talking about. So starting off with the word literal, it comes from the Latin and it means of, in, or expressed by a letter or letters. So when we're talking about literal equations, you know we're talking about something that has letters in it. Okay, so literal equations have more than one letter or variable. Up until this point, we have only looked at equations that have one variable, except early on in Algebra 1, where we might be substituting in and we're practicing the skill of substitution. But typically when we're solving an equation, we have just one variable. Now that variable might occur multiple times. Okay, so we might see the variable in more than one place, but it's still the same variable. So we are only solving for an x. We don't have the x and the y in the equation at the same time. So when you're looking about talking about directions, when it comes to literal equations, the directions will usually say something like this. It will say to solve for, and then list the variable that you need to solve for. So for example, you'll be staring at the equation and the directions will say solve for y. Okay, or solve for x, or solve for h. And when you see those directions, it means to get that variable alone. So it means that you're going to undo everything going on that side of the equation with that variable and move it all over to the other side so that you will have, say, just a y equals or just an x equals. So if the direction said solve for y, your final answer would be y equals some stuff. If it said solve for x, you would have x equal some stuff. And so that's our goal. So again, it's really important to be able to interpret those directions, because you can have the best algebra skills in the world, but if you don't understand the directions and what the directions are asking you to do, then you don't get very far with your awesome algebra skills. So here's our first example. So we have the equation 3x minus 4y equals 12. And here the directions are asking us to solve for y. Now I am going to take one quick step here and change that to a plus negative, because we don't want to lose that subtraction sign in our work somewhat. Now, when we get to the end, okay, our final answer should start with y equals, and then everything else is going to be on that other side of the equal sign. So we're getting the y all by itself on the left side. You could get it all by itself on the right side if that's where it was. It doesn't matter. But we're going to get it all alone, and then everything else needs to go to the other side. So let's take a look at what's happening here. I have the y. The y is being multiplied by a -4, which is a little bit easier to see than in the original notation. In the original notation, most of my students might say that it's being multiplied by 4, because they'll kind of drop that negative off of it and forget that it's that minus sign means you have a -4. So the y is being multiplied by a -4. We also have a positive 3x that was being added on to the -4y. And this is again where that changing of that notation from a minus over to a plus can help, because I will sometimes have students look at this and say that there is subtraction, and then they will try to undo it with adding, and they will try to add a 3x to both sides because they see that minus sign there. So by rewriting it, we can see that the minus sign actually goes with the 4y, and it's -4y, and this is a positive 3x. So if I do not want that positive 3x there, I can get rid of it by adding a -3x. So I'm going to go ahead and add a -3x to the left side of the equal sign. Okay, and so if I want to keep it balanced, I will have to add -3x to the right side of the equal sign. Over here, 3x plus -3x is 0, canceling out, and I will be left with a negative 4y. So a lot of times, if you don't recognize that negative as being with the 4, we can get rid of the 3x and then somehow that negative disappears with it. So we want to keep that negative there. That negative is with the y. So we have negative 4y equals 12 plus negative 3x. And then this is multiplication right there. So I will undo that. Now, as you're doing this, I want you to notice we are dividing the entire left side by negative 4. We are not dividing pieces of it. Everything on that left side is being divided by a negative 4. So when I go to divide the right-hand side, I need to divide the entire right-hand side by negative 4. I cannot do this. Okay, so if you're, don't write this down. Okay, that's supposed to be a 12. Okay, that does not work. Okay, that is like a big no-no, because here we're dividing everything, and here we only divided some of it, and this did not get divided. So this is definitely like not, that is not correct. You don't want to do that. Now, after you do this step, we will often take another step. So negative 4 divided by negative 4 is 1, and 1 times y is y. And what you might see is instead of one gigantic division symbol, you might see it split up into 2. Okay, and that will work the same way. So you're just, as long as you divide everything by negative 4, it's got to be both the 12 and the negative 3x. Now we can actually carry some of this out. So 12 divided by negative 4 is negative 3, and then a negative divided by a negative would give me a positive. And so this would be 3 over 4x. Now, you can write this a couple different ways. You could say 3x over 4. That would be fine. The more common way to see it is you'll see the x come out of the fraction there. So 3/4 x. In other words, you're thinking of it as maybe x over 1. So that'll be pretty common. What you cannot do, okay, so here, say these are equal, okay? So you can take it out. You cannot do this. Okay, so these two are the same. Yay, happy. That one is different. So the first one, the 3x over 4, you could get that by doing 3/4 times x over 1. And of course, x over 1 is just x, and that's why those two are the same. But if the x is in the denominator, that is something totally different. So now you're dividing by the x. Where I see that happen a lot in my classroom is, I'll show you, when students start to do their fraction bars like that. And so they'll have 3/4 x like that. And that creates a, I am not sure what you meant there, because that could be either or. That could be this one here, the 3/4 x, or it could be this one, and the way that it's written on a single line, it's unsure. So really try to avoid that. Pick one of these two ways of writing it, okay, and avoid that, because that is, it's just a little bit confusing. So that technically is the end of the problem. So we solved for y. The directions were asking us to get the y by itself, and we did get the y by itself. Now, when I go to rewrite this, so that is completely acceptable. You have done what the directions asked you to do. When we see that, a lot of times we'll see it written the other way, with the 3/4 x and then the plus -3, or with a -3, and there's a reason for that, and that reason would come up in a couple more lessons down the road for why you'll see that. But technically that's not part of the directions. If the directions say solve for y and you leave it like this, then you have solved for y. Same equation. This time we are asked to solve for x. So again, paying attention to the directions there. So first one, we were asked to solve for y. Now we're being asked to solve for x. So we have 3, oh, I didn't want that color. 3 times x plus negative 4y equals 12. I don't want the negative 4y there. I'm trying to get the x by itself. So the x is being multiplied by 3, and then we're subtracting that 4y. I can get rid of that by adding 4y to both sides. So plus negative 4y plus 4y equals 12 plus 4y. Right here, negative 4y plus 4y is 0. And now we would undo the multiplication. Just note we are dividing the entire left-hand side. And this time I'll do the split one just so you can see that you have some options there. So you can divide the entire thing or you can divide it in segments. Whether you want to do that or not kind of depends on whether any parts of it are going to divide nicely. If they are going to divide nicely, then you probably want to do it out. 3 divided by 3 is 1, and 1 times x is x. 12 divided by 3 is 4. And then I'll go ahead and do the same thing here. I'll kind of pull the y out. And again, that's optional, whether you want to pull it out of the fraction. But that is solving for x. So we have that equation with the x and the y, and you can solve for y, you can solve for x. Let's look at some more. Now, formulas are common literal equations, and usually by the time you've gotten to Algebra 1, you have encountered lots of formulas. In some science classes, teachers or professors may require you to solve a formula for a specific variable before substituting numbers in. So when I took physics in high school, there was a formula that like potential energy is equal to mass times the acceleration due to gravity times height. And maybe we knew what the potential energy was, and we knew the mass, and we knew gravity, and we were being asked to solve for the height. So some teachers are totally okay with you just plugging in and then solving the equation from there. My teacher in high school always wanted us to solve for the variable that we were asked for first. So if we were being asked for h, he wanted us to get it solved for h before we plugged any numbers in. And so this might become a valuable skill down the road or in a science class that you're taking now if this is something that your teacher or your professor wants you to do. It's just part of the way you set up your problems. So this is the formula for circumference of a circle. So circumference is 2 times pi times the radius. And the directions here are solve for r, which means we want to get the r all by itself. To do that, we have to look at what is being done to the r. Well, it is being multiplied. Try to put a little time sign in there. It is being multiplied by 2r. And we know from our algebra equation solving skills that if you have multiplication, you can get rid of the multiplication by dividing, and whatever you do to one side, you do to the other. We know that 2 pi divided by 2 pi is 1 because anything divided by itself is 1, and that is why they cancel out. So c over 2 pi is equal to r. You can leave it like that. That does meet the requirements of the directions. So if the directions just say solve for r and you have r all by itself, then you have solved for r. Most people would switch it around and say r is equal to c over 2 pi, because that is a little bit more comfortable in the way that we read from left to right and the way that we speak, but follow the directions for whatever it is that you are doing. Example 4, solve for 8. H, this is the area of a triangle. So the area of a triangle is 1/2 the base times the height. And we're going to be trying to get the h by itself. And there we go. And we got a couple things going on. So there's more than one way you can do this. The way that I would probably do this is I would start by looking at the 1/2 and saying, all right, like, can I get rid of that 1/2? Well, if I multiply 1/2 by 2, 1/2 times 2 is 1, and then I would have 1 times BH, and 1 times BH is just BH. So that would do it for me. So I would probably do this by multiplying both sides by 2. And then on the left, I have 2a, and on the right, 2 times 1/2 is 1, leaving me with BH. And now to get the H by itself, the H is being multiplied by the B. So I can divide by B, and same principle here, B divided by B is 1. Anything divided by itself is 1. And so 1 times H is just H. And so 2a over b is equal to h. And for most people, they would like to just switch that around because it feels nicer to have the variable we're solving for on the left. Now, you might do that other ways. Okay, so you could do it like this. Recognize that the 1/2 b is multiplying the h, and say, all right, well, I'm going to divide by 1/2 b. And so 1/2 b divided by 1/2 b is 1, because anything divided by itself is 1. And so you have h, and then over here you have a over 1/2 b. Now, technically that is the same thing, because to divide by 1/2 is the same as to multiply by 2. That goes back to what it means to divide. You can go back and check out my video on dividing real numbers, and we could do a deep dive into that. So if that's very uncomfortable for you, I'll try to remember to link that in the description box when I post the video. But if not, just go and scroll back into the video playlist and you can find it. That technically is fine. A over 1/2 b. If the directions say solve for h, technically you have solved for h. Most of us do not want a fraction sitting in the denominator though, so I would not advocate that as being the best way to do it. Okay, one last example. This one is a financial formula, and I don't want to get too much into what the formula is, but I'll do a quick explanation of it. The A is the amount of money that you have in your bank account. Okay, amount. It does not want me to write that. There we go. P stands for principal, and this is your starting amount. Okay, so that's P is for the word principal. And then the PRT is actually a formula for how much interest. So the amount of money in your bank account is equal to the starting amount plus the amount of interest that you make on it. That is the super short version of what that formula is. And we are being asked to solve for P. Now, this is an interesting problem because you'll notice that there's more than one P in the formula. So how do you get the P by itself? Well, you could try to divide by the RT, okay? But remember, you got to divide everything by the RT. And now you've got, there's like a better way I could have written that. So you could divide this by RT, but you can't divide the entire left side and part of the right side, which means that you've got to divide this by RT. And so then you land here, okay, because RT divided by RT is 1. But now all you've done is like you've moved the RT. Like it feels like, okay, we made that worse. And you could like play around with this a little bit, but here's the thing that is like the trick to this. This is why it's good to do example problems. If you look closely at this, you see a P here and a P here. Now, what we're going to do is undistribute the P. So for a second, I'm going to do a little bit of scratch work over here. If you had P times 1 plus RT, okay, and you were going to distribute that. So P times 1 plus P times RT, P times 1 is P, and P times RT is PRT. What we're going to do is we're starting here, and we're going to go back and rewrite it that way. So we have P, and that would be the same as P plus P times 1 plus RT. That process, there is a term for that. It's called factoring. It means that you're looking at an expression and deciding, well, what times what gave me this, and you're factoring it out. Now that we see that, we can see that that is P times 1 plus RT. So if I want to undo multiplication, I can divide by 1 plus RT and do that on both sides. 1 plus RT over 1 plus RT is 1 because anything divided by itself is 1. And so that will get the P by itself. And there you go. That is a pretty challenging problem there. And I think the first time you see something like that, no teacher would probably expect you to figure it out on your own. It's the kind of thing that you have to see somebody do it and say, oh, like that was a slick idea there. Okay, so there we go. Please like this video if you found it helpful and subscribe to the channel for more math help videos. Let me know if there's something specific you would like to see, and I will see you in the next one.